right. Well, thank you folks for joining this Wednesday walkthrough of Kaleido. I hope everyone's staying safe and staying healthy wherever you are. Today I want to focus on a handful of the new features and enhancements we've added to Kaleido over the last couple of months. Not a ton of content, excuse me, to go through today. I just want to draw your attention on to a couple of features that we have. Makes your life a lot easier and has also made the experience inside of the console or via the APIs for that matter a lot easier. So I just have a few slides to walk through the initial context of Kaleido, and then we'll jump right into the platform, show you those features that I alluded to, and then actually show you guys one of these turnkey applications that we've developed internally that can greatly accelerate a whole bevy of different use cases and different projects. So let me just go ahead and share. So at a very, very high level, Kaleido, really three core tenets define us: built for modern business networks, very much industry use case agnostic. We have a slide that touches on a lot of the different players that we have running in production. So you'll see how expansive and how diverse that is. The platform itself, very, very easy to use, radically simple. Whether in the console, creating networks, creating blockchains, standing up services, or at the developer layer with our APIs. There's a REST API for every service, every admin action, and even REST APIs for speaking to Ethereum smart contracts. And then lastly, enterprise in our DNA. So you get a lot of the checkboxes: high availability, disaster recovery, advanced key management, auto scaling. All those features come out of the box on Kaleido. Our approach has been trying to flatten the curve, making it very, very easy to pick up the technology, not concerning yourself with having to own and operate nodes, understanding crypto primitives and P2P messaging protocols and consensus algorithms, and all of the new EIPs that come with Ethereum or other blockchain protocols, and then giving you the confidence and the runtime infrastructure to quickly advance into pilot phases and ultimately into production, running your resources on different clouds across the world, maybe even on premise, and injecting high throughput workloads into the blockchain. One thing that we always harp on is that the blockchain, while incredibly important, it's a really small piece in the overall stack. We see that you need a lot of answers and a lot of services that account for, where the data is, how are we going to integrate that off-chain data, how do we model that data on the blockchain, whether with just a hash, whether in plain text, or whether with complete obfuscation. At the transaction layer, you have a lot of questions around privacy and the consumption of events. This is one key feature that I'll show you guys today, how it's very, very easy to integrate your blockchain, your smart contracts with your critical back office systems. The middleware component, obviously very important as well, allowing apps to speak to each other, using oracles and using trustworthy data feeds, connecting to, for example, your existing LDAPs or existing identity access management systems. And then at the fun layer at the top, we'll look at this today. There's a lot of questions around digital assets and tokens and how you can easily create that server-side application without having to become an expert in Ethereum, in Hyperledger Fabric, in Corda, with all these thick client libraries, SDKs, and really complicated esoteric APIs. As I mentioned, just a quick snapshot of, Kaleido is applicable to all business networks and all verticals. So we see huge banks, huge energy majors, retail, finance, entertainment, etc. All these customers have different use cases and different production applications, but all running for many, many months, and some over a handful of years in production on Kaleido. Promised I would touch on a few of the enterprise grade features. A handful of these are things that you just get out of the box on Kaleido, as I mentioned. So ISO certification, secure key management, HADR, the ability to have business continuity, not only from Kaleido, but also delegated to your existing cloud infrastructure. So being able to take snapshot backups, of your node, of all the key material, and of the corresponding databases and chain state. And then a lot of work on incorporating with your existing cloud estate. So log streamings, key management, backups, as I mentioned, private traffic, and even role-based access control with your existing LDAPs. And then recently, we've taken a lot of strides in making it a lot easier to actually stand up and operate a fully managed Kaleido node on your own private infrastructure. And this can run, in a DMZ if you're a financial institution. This could run on your own laptop. This can essentially run in any on-prem data center, any server, or any private cloud that makes sense for your enterprise or for your use case. So if there is an interest in private stack, I'm happy to talk more about that offline in one of the upcoming Tuesdays, not this upcoming Tuesday, but the following Tuesday, 13 days from now. Our head of engineering will be demoing this feature and show you guys how easy that is to stand up and configure. Last thing I just want to touch on is that we do have standard software as a service pricing models, but we're also happy to work with customers and try to meet you at the specific point of the journey that you're on. So if it is just sandbox and dev, or if it's pilot production, or if you're an R&D department and you want to just do a lot of high throughput testing and have access to all of the bells and whistles in Kaleido, we have very affordable bespoke packages that we can help work with you on to give you all of the resources that you need. So those are the slides, went as quickly as I could. What I want to touch on today are, like I said, a lot of the new features that we've added in Kaleido. So I'll just scroll through these. Yesterday, Vinod, one of our protocol engineers, demoed hard forks, show you how to pick up the Constantinople block, be able to leverage new opcodes in the EVM, and essentially take your outdated Ethereum blockchain and apply those new configurations and those new improvements on them without losing your existing chain state. So allowing your blockchain to upgrade dynamically as your business network needs to upgrade. We recently added a new region on Azure, so we have support for not only the US, but Europe now. So Paris is available on Azure. Event streams, as I mentioned, we'll spend a little time on that and show you why this is important and how easy it is to configure. Multi-factor authentication, giving you heightened security on your enterprise logins into Kaleido. Pretty straightforward to stand up, enable, or disable this feature, but we do have it. Additionally, or tangentially with that, we have Google Login as well. Block signer, vote in, vote out. We have scenarios, where you might have an organization that does want to participate in the algorithm, then the business network changes, and maybe they only want to participate as an auditor or as a validator. Very, very easy to dynamically configure your environment, add nodes as signers, remove them as signers, etc. Upgraded optics on the billing dashboard, so very easy to see your forecasted billing and your current billing, and then some new improvements with Quorum and Tessera and our Ether pool inside of Kaleido. So I'll touch on the Ether pool and event streams today, and then we can take any questions or dig deeper into any other features that we have. And as I mentioned, I'll show everyone that full, that turnkey application that we have as well. That may be of interest to folks, and I'll show that at the end, but let me just add the caveat that it is open source. So if there are additional features or integrations that you might want with that, it's very easy for the Kaleido engineering team to layer those in, or for your own development shop to, for example, add additional encryption keys or add privacy techniques into that application. So here I am inside of the console. What I'm going to do is I'm going to just go ahead and start from scratch, and I'm going to create a new business network here. So I have an existing one called testnet, but I'm going to use that here in a second to show you guys that application and show you some other features. So I'm going to create a business network. Sort of the synonym for that is a consortium. So you can use whatever nomenclature you prefer. We'll call this Walkthrough Wednesday Business Network here. You could upload some legalese or submission. Go ahead and click next. And now you want to whitelist a cloud and you want to set a home region. This is going to host the metadata for your consortium. So it's going to know about the participating organizations, the memberships, etc. And it's also going to be a whitelisted cloud and a whitelisted region, meaning when we go to create an environment, an actual blockchain, we'll have this cloud and this region available. One thing about Kaleido is we don't scope you. It's not a binary decision. So you're not operating solely on a specific cloud or solely on a specific region. That was probably pretty obvious when I mentioned that we have private stack support as well. But you can decentralize or hybridize, I know that's not a word, but turn your network into a cross-cloud or a multi-region network by whitelisting additional cloud providers or additional regions within the existing cloud provider. So we see we have a handful of APAC and Europe regions, and then we have Azure with US West and Paris as well. So you can grab as many of these as you want when you're creating the network, and you can whitelist them after the fact as well too. So I'm just going to stick with AWS on Ohio, but this is incredibly, incredibly easy to whitelist at that point, or as I mentioned, after the fact to whitelist it. So here's sort of the container for the business network, the namespace, and all we have is a single membership, the founder of this network, and we can do one of two things here. We can onboard external entities, and we can even apply permissions about what they're allowed to do inside of the network. For example, are they allowed to extend invitations? Are they allowed to create environments? Are they allowed to create nodes as signers, etc.? Or in the POC MVP phase, a really common technique is to create what we call multiple memberships. And this is useful in a couple scenarios. This is useful for just mocking out the future composition of the network. Maybe you don't want to decentralize the network. That's too expensive. That takes too much coordination at this point in time. Or maybe your network is going to operate under the benevolent dictator model, where we have a single central entity that's going to proxy access into the network, and maybe even potentially layer on some sophisticated role-based access control. So memberships are a very powerful construct in Kaleido, whether mocking out the future participation or whether operating on someone's behalf. So you can do that very easily under the governance banner here at your business network layer. So this is the business network, and now for the fun part, we actually create what we call an environment, and this is a blockchain inside of Kaleido. Now, within your business network, you can have many, many environments. Every environment is an isolated firewalled namespace with all of that layer 2 virtual networking, cross-cloud compatibility, completely confined and firewalled within that environment. So you're going to have no leakage, no certificate security leakage, state chain leakage, etc. All of the state, all the services, all the nodes are completely confined inside of that environment. So typically we'll see folks create one called development or sandbox. Then, as the infrastructure matures, as the use case kind of gets steam, we create maybe a user acceptance testing, a staging, and then ultimately and ideally a production environment. We have some constructs that make it very, very easy to promote code, promote smart contracts, and migrate your applications from a dev or a staging very seamlessly into production. We see here that we can choose this as cloud only, but as I mentioned, we also have support for hybrid and on-premise. This is a switch that we're going to need to flip internally for your organization, for your Kaleido account. So if this is something of interest, or if this is a security requirement for your consortium or for your enterprise, just go ahead and click this button and contact us. We can have a business conversation and ideally flip that switch for you. So I'm going to go cloud only, obviously, click next. Now we can just choose the node client, the provider, and the corresponding algorithm. And we give you a bunch to choose from under the Ethereum banner. We have Geth, which is just kind of the Go implementation of the public Ethereum protocol. But we also have some private variants, some Quorum and Hyperledger Besu, which are very, very similar at the protocol layer as Geth, but they support private transactions. They essentially have a neighboring module called Tessera and called private transaction groups on Hyperledger Besu that support private state on the blockchain. It allows for bilateral or multilateral transactions to take place, but certain participants in the network may not be able to execute those transactions and generate or manifest the underlying world state for that. Super useful for supply chain or for certain financial use cases. I'm going to go with Geth and proof of authority. Definitely the most hardened, definitely the easiest. What we see for the vast majority of enterprise deployments, though, is a Quorum and IBFT orchestration. Happy to talk more about the configurations and the protocols, or you can easily just click this link, which is written by our head of protocol, and it deep dives at a very academic layer into the clients and into the algorithms as well. So recommend reading that blog article if anyone's interested. So here's the container, here's the firewalled namespace for our environment, and now we just go ahead and bring it to life by creating nodes. And we're going to bind nodes, bind services, and bind security credentials to a membership inside of Kaleido. So you can have that very, very logical association of service or a node with a membership, whether you're owning that membership or whether you're proxy operating that membership. So I'll just create node number 1. We'll leave it in AWS US East. I could choose to integrate with my native cloud suite, as I mentioned. So we have key store integrations, backup, log streams, private traffic, and even that role-based access control. We've covered a lot of these on Tech Tuesdays, so I'm going to skip these for now. But if there are questions, please just throw them into the chat and we can take those as they come. And then lastly, based on the scale of my application, based on the anticipated throughput, we have different footprint sizes for the nodes. For context, a small node can accommodate 5 concurrent connections and 5 requests per second. So very, very useful for just getting started and, sending in small workloads. But as your application, potentially scales horizontally, and as you may be asynchronously streaming tens or hundreds or even thousands of transactions, then a medium or a large node starts to make more sense. Lastly, choose if you want the node to actually be a signer in the algorithm. Click finish, and then boom, here's your private Geth proof of authority, permissioned, firewalled blockchain that's been brought to life. So this node will take maybe 30 seconds to fully initialize. While he's coming up, I'll just create a second one to make the algorithm happy here. Go ahead and click finish, and then we can go back to the dashboard for our environment, and we have full line of sight into the status of our resources. I'll pause here for a second. We'll just go ahead and watch these guys come to life. And then what we'll do is we'll go ahead and take a look at the Kaleido Easy button for creating what we call a contract project and very, very easily interacting with some Solidity source code, removing a lot of the barriers that tend to accompany Ethereum and Web3 development. So what I'm gonna highlight here is where Kaleido removes the need for you to become an Ethereum expert, also removing the need for you to re-architect and rip apart your existing hardened back office business processes, kind of the beating heart of your existing enterprise and your existing cloud IT infrastructure. So we see our system monitor, our indexing node has started up. This is what we use for populating the data in our block explorer and a lot of our health and metrics monitoring. And then obviously the nodes are going to maintain the ledger, and these are the guys we can connect to submit transactions. So those guys started up really quickly. I'm going to hop back into my network tier here, and we're going to create what we call a contract project. And this is a construct that is shared across the business network, and it gives everyone line of sight into where the source code is coming from, and it lets everyone know exactly what they're interacting with on the blockchain. So you don't have to say, oh, I'm just talking to this random compilation of bytecode, but I don't really know what the business logic is. What this allows you to do is this allows the entire business network to have a shared source code repository. They can iterate on this, this source code, this Solidity that is going to be leveraged by their industry, by their consortium, and they can all know exactly what is being executed on the blockchain. So we create these compilations within a construct called a contract project in Kaleido. Obviously, I'm going to use Ethereum as the door here, but you can see that we support Corda as well. We've touched on Corda on a few of these in the past, but sticking with Ethereum for today. And I'm going to use this simple storage smart contract. It's incredibly, incredibly trivial, but it's really good for newcomers to Kaleido and to Ethereum to just wrap your head around very, very basics of smart contracts and a lot of the shims and a lot of the middleware that Kaleido provides for you. So I'm going to import this source from GitHub, and what Kaleido is going to do is Kaleido is going to use a little serverless function in the cloud, and it's going to do all the heavy Ethereum lifting for us. It's going to actually compile the source code, and it's going to spit out bytecode and a binary interface, and ultimately it's going to generate REST endpoints for this Solidity smart contract. And I'll show a diagram here ultimately of what we're going to leverage. So here's the source code that we want. It's called simple storage, as I mentioned, and it has a single global variable that's a positive integer, and it requires an argument to the constructor when we instantiate it, and then it has two methods, a set and a get. What it also has is it has an event that we call data stored. And this event is just going to emit the argument that we pass to the set method every time we invoke that method. So here we've defined the event data stored, just emit the unsigned integer. And now when we invoke the set method, we say here that we want to emit that event that we've defined up here. And this is what allows your decentralized blockchain network, all of the various diverse participants, to have real-time notification when a counterparty perhaps makes something available for sale, or uploads interesting data onto the blockchain, and you want to be able to react to that. Either in real time or via automation. And events are incredibly, incredibly powerful. So we'll look at the submission of transactions, and then we'll look at the consumption of events, all hand in hand with this smart contract. So first thing I'm going to do is I'm going to take the URL to this Solidity source here, and I'm going to upload it into a new compilation. So I'm going to call this version 1 of simple storage. And inside of our contract project namespace, what we can do is we can have many, many, many compilations. And this probably stands to reason, but very, very rarely are you going to get your business logic right the first time. Smart contract solidity are new paradigms to a lot of folks. So it may take 5, it may take 10, 15, who knows, 20 compilations until you really, really harden that source code, that business logic, and have everything working as you expect it to. And the nice thing too is that, if you have syntax errors, if you have compilation failures within your contract project, you can very, very easily delete those so you don't end up saturating that namespace with a bunch of failed compilations that can't even be deployed into your network. So you can keep it very streamlined and very clean. So here's the path to that Solidity file. There's only one contract in it, so we don't need to enumerate anything here. It's public, so we don't need an access token. And then I'm just going to let Kaleido auto-detect all of the rest here. So I'll click Finish, and this will compile in about, 20 seconds, for example. And what will happen is it'll spit out, as I mentioned, the bytecode and the binary interface, and Kaleido will then allow us to generate REST APIs for this smart contract. And what we're going to do is we're going to use our REST API gateway. So what we've done here is we've uploaded source code. And as I mentioned, Kaleido will do that compilation, the heavy lifting, and then Kaleido will generate APIs for us to talk to. So now over here at the application layer, think of this as your cloud estate, as your VPCs, your EC2 instances, what have you, where you have your existing stack running. What you do not have to do now on Kaleido is inject this existing application with a thick SDK or a thick Web3 library. All you need is a basic little Swagger client, and you can speak to Kaleido using basic REST web development paradigms. Just submit lightweight JSON, whatever argument the method in that smart contract needs. In our scenario, it's just going to be a positive integer that's under 100, not incredibly interesting, but this could be hashes, this could be metadata, etc. And this layer right here, we call it ETH Connect. It's underpinned by Kafka, best of breed messaging technology, and it's going to do all of the ugly Ethereum lifting for us. It'll do the hexadecimal representation, it'll do the high throughput management, and specifically, it's going to do this nonce or this sequencing management. And this is a huge gotcha in Ethereum, making sure that the signing account that's submitting the transaction into the network has the right order of transactions. If you're using a library, you need to make this API call called get transaction count. You also need to do these estimate gas calls, and then you might need to do WebSocket polling for the transaction receipt. And it can become a very, very heavy orchestration. And you can also start seeing rate limiting tryouts on the nodes. As I mentioned, we support 5 requests per second, but when you're using a Web3 library, you have all sorts of different API calls. And Kaleido is agnostic to the type of API call. We don't care, we just see it as a HTTP or a WebSocket call coming in. So if you need 6 API calls to just do 1 invocation and 1 consumption of the receipt, you have a chance to start hitting your rate limit just with a basic submission of a transaction. So this removes so many API calls, and it can greatly, greatly accelerate your whole application lifecycle. The other thing too, sorry to drone on about this, but the last thing I want to mention is the flexibility for how you can sign the transactions using this layer. And we give you a lot of different techniques. So if you're using a Web3 library, you typically sign those transactions externally, or you enumerate a count on the Ethereum node that you want to sign that transaction with. Now, using this layer, you can of course use an account that's on the Ethereum node, but you can also leverage Kaleido managed wallet services that you can integrate with master encryption keys for heightened security. We have basic managed wallets, and then we have HD wallets, which give you about 3 billion accounts, billion with a B. Great for one-time usage, sign and throw away, or if you want to manage Ethereum accounts on behalf of hundreds or tens of thousands of end users. We also support integrating these keys with cloud HSMs. And this is an awesome enterprise security sort of accommodation here, where you have that heightened security, assurances that that private key will never leak from that piece of hardware, but you can also leverage this simple submission layer in our Kaleido Easy button. So our supported HSMs are AWS KMS, Azure Key Vault, and then HashiCorp with a signing extension. So if you actually use the HashiCorp orchestration, you could run that on your own laptop in your private data center in a private cloud. It's essentially just a piece of software, a server, and you can stand that up wherever you want. So we have a ton of flexibility on how you're ultimately going to sign these transactions. And then the other piece I want to show you, that was the submission piece, and this is the consumption piece. And all you have to do here is just teach Kaleido about where you want your events to be delivered. Tell Kaleido about, an API endpoint, and this can seamlessly integrate, with an off-chain database with your application, so that not only is your application and your business processes being notified in real time, but you don't have to go into the blockchain for queries here. And so this is also underpinned by Kafka. If that API is unavailable, these events are not going to get discarded. They're going to do the checkpoint retries, and you're going to get reliable delivery of that event to your API endpoint here. So events and the easy submission layer, as I mentioned, sort of a bi-directional pipe, but very, very powerful when you combine the two together. So sorry, a lot of talking there, but that's really, really powerful feature in Kaleido, so wanted to draw your attention to it. So here's our compilation here. We see the ABI, we see the bytecode, we see the empty dev docs there at the bottom, and then we see the source of truth. We see the git commit hash, and we see where this source code, where this solidity came from. And now we can go ahead and promote this to an environment, and by extension, we'll create open APIs. We'll create those REST APIs. So I'll just call this SS, shorthand for simple storage. I'll promote it to dev. And as I mentioned, the idea is harden, iterate on your contract project, create a bunch of compilations, promote them to dev, to UAT. Once it's acting as expected, you can very easily take that exact same source and promote it into your production environment. So this is that clean DevOps, promotional pipeline that we have here. Okay, so here's our gateway API. Now I can go ahead and view that gateway API. And what this is going to do is this is going to show us the methods that we were looking at inside of that simple storage piece of Solidity. This is not actually a deployed smart contract. This is just a definition of those methods, excuse me. So we see this missing route for the address, the smart contract address. But we see our get, we see our query, actually two redundant methods inside of the source code. But we also see our event here, data stored, and we see our interesting method, our set that allows us to upsert new variables or new state for our variable, excuse me. So the KLD from parameter, this is where you enumerate what account you want to sign the transaction with. It's going to default to the single Ethereum account that you get for free on your node. You can, of course, create multiple, Ethereum accounts on the node, but this will also work with, as I mentioned, a managed wallet, whether it's an HD wallet or a Kaleido wallet, or it'll also work with a cloud HSM. So any account, essentially, that Kaleido knows about that's been created on the Kaleido server side, you can enumerate any of those accounts here. And so, I mentioned the HD wallet, which can have hundreds or thousands or even billions of accounts. This would be very, very easy to have, an end individual authenticate into your LDAP, into your identity system, and then map them to an HD wallet account and then sign on their behalf right here. So what we're doing here is we're going to instantiate this simple storage smart contract. Typically in Ethereum, smart contracts instances are represented with a hexadecimal address, 0x and then 40 characters. Not super lovely to interact with. So what we allow you to do is give human-friendly naming conventions here. So when you're instantiating or deploying a smart contract, you can use this KLD register parameter, and you can apply any naming convention that you want. And this is useful because, you might want to take this gateway API, this compilation, and create multiple instances of it. Maybe you want an instance for, your Americas department. Maybe you want an instance for your European department, or maybe you want to segment it across, different verticals inside of your enterprise. If the business logic is extensible, to multiple areas inside of your business network, then obviously you're going to want to have different names applied to it as well. So we're going to pass an argument to the constructor that was required inside of the source code. I'm just going to give it 1, 2, 3, and this will bring that smart contract to life. Now, I'm doing this inside of the Swagger interface in Kaleido, but for any middle school, high school, entry-level programmer, this is incredibly trivial to do, at the programmatic layer. as I mentioned, all you need is a Swagger client inside of your framework, and then you could use, whatever language you prefer, Python, .NET, Node.js, what have you. So here we've instantiated this gateway API. We can close this Swagger interface, and we see that we took this API or this compilation and we turned it into an instance right here. So we can open up this instance, and now we're actually talking to a specific smart contract on Kaleido. We're not just talking to the methods, we're actually talking to an on-chain deployment, an instance. And we'll take a look at the Block Explorer here in just a second to prove that that was actually a real deployment. The last thing I'm going to do here is I'm just going to invoke this with a trivial little argument. We'll give it 29 for the date here, and then we'll hop into the Data Explorer or the Block Explorer and see what we did. So this will execute here in about 1 or 2 more seconds. We're on Geth and proof of authority, so you get a block every 5 seconds. So we have 2 transactions in the network now. I can close this. I can go to my Data Explorer. I can go to the Block Explorer, and we see our instantiation, our creation of that instance, and then we see our invocation of that smart contract. I can actually click on this this transaction here, and we can inspect some of the interesting details. We see who signed it. We see where it went, the actual smart contract instance. We can click on any of these for more details. We see the consumed gas. And then we can even see the method that was invoked and the argument that was passed to that method. So the Ledger APIs inside of Kaleido and the in-console Block Explorer provide you with a ton of data and a ton of information about what's happening, with transactions inside of your business network. Gives you really, really powerful line of sight. So that was just kind of the easy button of how to upload some source code on Kaleido and how to get started really, really quickly and send your first few transactions. The other piece I want to show you is that opposite direction inside of the REST API gateway, the event streams. So back inside of my environment, I'm going to click on the Apps and Integrations tab here, and we're going to go down to our event streams. So click the event streams, and I'm going to create a new one. And we're going to use this emitting from node number 1. It doesn't really matter, it would emit regardless of what node we choose here, but I own node number 1, so I'm going to go ahead and configure this against node number 1. You could use the event stream, you need to name it. Essentially, this is just going to be the endpoint where you're pointing stuff, so I'll just say my API endpoint. Again, this could be a serverless function in Microsoft Azure, a Lambda function, or for quick testing purposes, there's some free subdomain services like this request catcher, which I'm going to use actually. So just create a name for your event stream, choose how you want it to be delivered. It's just HTTP as of right now. And then we want the URL. This is the important piece here. So I'm going to go to this request catcher service. I'm just going to create a dummy subdomain called Kaleido123. And now we can teach Kaleido about this endpoint right here. So I'll copy that string. We'll create that as the URL. We see lots of options for configuration, batch size, timeouts, retries, etc. And then you can add additional headers, whether you want to add metadata, specifying the types of payloads, or whether you want to add security if this is protected by a bearer token or an API key. I'm going to leave this open because it's just free service, doesn't matter. So go ahead and click finish. Now we've created the event stream. And now within it, we need to create what we call a subscription. And if you remember, when we looked inside of this smart contract, we see here that we have this event called data stored that's going to emit every time we call the set function here. So what we'll see inside of our REST API gateway is the ability for us to subscribe to this event. And the critical thing here inside the smart contract is that it's been coded to emit that event. If we subscribe to this and it didn't, none of the functions actually emitted it, we wouldn't get anything interesting. We wouldn't get anything at all back to our endpoint that we configured. So if you are writing a smart contract and you define an event, don't forget to make sure that you emit it on the methods that you care about here. So we've created the event and now we need the subscription. So I can scroll down on my event streams tab here and I can just go ahead and add a subscription. So I'm going to call this data stored. And now I'm going to select a gateway API. You need to teach Kaleido about the smart contract because it's being emitted via our Kafka tier, via our messaging tier, and via that REST API gateway. So I'm going to pause on this for a second, but If you did, for example, use a Web3 library to compile and deploy a smart contract, you have a bunch of existing state on that smart contract, and then you come to Kaleido and you say, hey, man, I really want to leverage these event streams. This looks like it could be really, really powerful. And I want to get all the historical events for that smart contract too. That's no problem. You can still do that. You simply need to create a compilation. You need to create that API gateway for your existing smart contract. So you can import it from GitHub, or you can just supply Kaleido with the bytecode and the ABI, and we'll give you all of those historical events to any endpoint of your choosing. So this isn't a binary action. You don't have to start by creating a gateway API. You can go the classic Web3 route, and then down the road, 3 months, 6 months, a year from now, if you realize that you want to get a bit more sophisticated, in your application tier, in your back office infrastructure, just go ahead and create an accompanying gateway API for that Web3 deployed code, and then boom, you can consume all of those historical events, or you can consume the events from any block number that you wish. We went the happy path here, and we created this, through the gateway API, so Kaleido already knows about it. And then the last thing I need to do is just define the event. And everything gets indexed for free for you here. So this is incredibly, incredibly easy. You don't need to do anything, complicated at the programmatic layer. Once Kaleido knows about the source code, we'll surface everything for you. Choose if you want it from a specific block number or from the latest block number. We're good with latest here, but if you do want historical data, just go ahead and choose block 0. And then lastly, choose an instance. We only have one instance of that gateway API, but if you had a bunch of instances of it and you just wanted to subscribe to the signature, then you can go ahead and forego this field here, and we'll deliver you all of the events that match that signature there. So I'll just select our instance that we deployed, go ahead and click finish. And now all we have to do is go back into that gateway API and just invoke our set method, which is coded to emit the data stored event. And please feel free to chuck any questions in the chat if anything is unclear here. Hopefully it's not. I tried to show the source code as clearly as I could, but this can be potentially a little tricky to understand on the first couple goes. So I'm going to go back into that instance right here. We're going to inject it through node number 1, our transaction. And all we're going to do is invoke the post method here. So just give it a new argument. I'll give it 30 this time instead of 29. Go ahead and click try. And now if we go to our API endpoint, our serverless function, our application, we're going to get that real-time notification of the event. We see the smart contract address, we see the block number, we see the transaction hash, and then what we're going to see is we're going to actually see the argument that we passed here. And you can code these events to include more interesting things. So one thing that you don't get for free, and it's important not to conflate events with actual Ethereum transaction receipts. They're not the same. The events are only going to emit what they're coded to emit. So for example, one thing you don't get is the message.sender. You don't get the signer of that transaction. This is a very, very easy field to add into the event. And this may be something that's really, really interesting to your application, to your business network. You want to see, what party actually submitted this new data into the network. So all you need to do is just create a bit of a more comprehensive event. All ours did here was emit that data field, the argument that we're passing to that method. But if you do want more information, you just add additional fields into that event. So there is an example of the transaction submission and then the event consumption as well. Got about 20 minutes left. There were 2 more things I wanted to show. I think we should have time for that. So the next thing I'm going to show is our revamped Ether pool. So inside of Kaleido, every environment inside of the Genesis block, it comes bootstrapped with 1 billion Ether. And we store this Ether inside of the default Ethereum account on our system monitor node. Now, it is possible to create environments and actually fund external accounts. So if you don't want the system monitor node to be the custodian of that Ether, essentially the custodian of the faucet, what you can do is you can create your environment. We're adding this to the console here shortly, but you can do it right now with our APIs. And you can just enumerate a single external account or multiple external accounts that you want to allocate that Ether to. So maybe you could give $250 million to one account, $500 million to another account, and $250 million to another account. And then from there, you can disseminate that Ether however you want. The default way is to have it on the system monitor node. So if we use our digital assets construct here and click on dashboard, we see that we have our Ether pool. And I'll show this in conjunction with MetaMask and Remix here. You need a bit of gas inside of, you need a bit of Ether inside of your MetaMask account in order to submit transactions into the private permission Kaleido chain. So what I'll do is I'll just go ahead and fund my MetaMask account here. So I'm going to use this, copy this to the clipboard, and then we'll just go with the fund account. So we see that we have all of the indexed accounts that Kaleido knows about. These are just the 2 default node accounts. If we had an HD wallet or a managed wallet or a cloud HSM, we would see those there as well. And then I'm just going to go ahead and create or input my custom address here. We're going to do 100, and I'm just going to go ahead and fund that account inside of MetaMask. Now, we're not going to actually see the presence of that because I haven't connected into Kaleido. I haven't created a custom RPC URL. So let's go ahead and do that right now. And then we should see this 100 Ether manifest inside of that account. So I'll go back to my dev dashboard right here so I can see my nodes. And I'm going to click on node number 1. Now I can click on the wallet and we'll see the default Ethereum account. But what I'm interested in is actually this connect app button. And this is going to populate us an RPC endpoint. This is going to populate us something that an application or a wallet plugin inside of our browser can securely connect to Kaleido through what we would call a fully qualified URL or RPC endpoint. So every ingress, every service, every node inside of Kaleido is protected by boundary security. So we need that secure TLS authentication. And we authenticate using what we call app credentials inside of Kaleido. So these are 256-bit strongly generated credentials, typically passed over basic auth. And it's basically just a username password construct. But in the scope of MetaMask, what we're interested in is this endpoint right here. And what it is it's the basic RPC endpoint injected in line with our security or our application credentials. So here's the username, here's the password, and now we can see in line that it's username : password at the RPC endpoint of the node. So I'm going to copy that to the clipboard. I'm going to go into MetaMask and I'm going to create a custom RPC URL that could be used by Truffle, by our application, or in this circumstance, it's going to be used by Remix with an injected Web3. So we'll call this walkthrough Wednesday Kaleido endpoint right here. And then we're just going to paste that URL right there. Go ahead and save that. It's going to ask me to reload the Remix instance. And now we can open this up and we see that it's funded with 100 Ether. So very, very easy to, for example, fund external accounts, or alternatively, I could have funded any of those accounts that were indexed on Kaleido. One final thing I'll show you is that if you do want to check the balance for your Ether pool, all you have to do is just click on your system monitor node, click on the details here. Click on the signing accounts here, and you'll see the decremented balance. So it does start with $1 billion, and as you start draining that faucet and dwindling it down, everyone inside of your environment, inside of your business network, will be able to either call an API and see this balance, or if you're an administrator, you can see it directly inside of the dashboard here. So another super easy way to get started, using Ethereum and talking to Kaleido with sort of the middle ground between a fully fledged Web3 external application, is to use this, this IDE environment here called Remix. So I'll just show you a very, very simple example of using, again, some pretty trivial source code right here, just storage.solidity, which is arguably the exact same thing that we just looked at with simple storage. It just takes a positive integer, has 2 functions, a store and a retrieve. It does not need an argument to the constructor on this one. So we can go, let me refamiliarize myself with Remix here. So first we can just go ahead and compile this guy, and then we'll go ahead and change it to an injected Web3. So it compiles fine, change this, we'll go injected Web3, and this is gonna load that MetaMask instance for us. And we should be able to go ahead and deploy this right here into Kaleido. So assuming I did everything right, we should see notification of a successful transaction. And once it's deployed, then we can go ahead and interact with this smart contract here. So it deployed, we can open it up down here, right there. If we wanted, we could hop back, into our data explorer, and we could see the existence of that transaction right there. There's the deployment. And then lastly, we can just go ahead and call that store function that we have here, 123, for example. So again, this will integrate with our MetaMask, with our external account, that 0xb50 account that I have in here that's been funded with gas. Go ahead and confirm that transaction. And now we've seen sort of an example of an external application submitting transactions into Kaleido, deploying and invoking a smart contract. So there's our second transaction that we just did from Remix. Okay, so about 10 more minutes. Again, please chuck your questions in the chat if there is anything, or if there is a feature that you'd like me to draw some more attention to. But the last thing I'm going to show here is I'm going to actually show this application that we have that we can actually share with clients regardless of the size of your shop. And this is something that's going to remove a lot of the heavy lifting that is required for getting projects off the ground, whether it's just a POC or an MVP. There still are a lot of APIs that need to be stitched together, and a lot of services that you need to understand where they fit inside of that overall stack. So I have another business network here called TestNet, and inside of it I have an environment called Data Sharing Demo. And this is really, really straightforward. It's leveraging IPFS for the storage of our private data. I hope everyone's familiar with IPFS, but it's just a peer-to-peer file sharing construct. It can be used, in the public internet with mainnet Ethereum, or it can be used, kind of in a permissioned or private scope, where the nodes and the cluster are, again, completely firewalled within inside of your environment. The standard operating procedure with IPFS is simply to just upload a file. It gets sharded, it gets disseminated to all the nodes in the cluster, and then it's basically censorship resistant. If you need heightened security, what you would typically do is you would encrypt that payload before you upload it to IPFS, and then even if a counterparty had possession of the hash that represented that file, they wouldn't be able to turn that ciphertext back into plain text. But with the standard implementation of IPFS with public sharing, all you really need to know is the hash of the document, or the whatever file in question. It could be a video, it could be an image, an actual 300-page legal contract. All you need is the hash in order to retrieve it and make sense of it. So that was a kind of a tangential comment about privacy here. But what we're using here is we're, again, using our gateway APIs for easy interaction with the smart contract. This is just a document manager smart contract here. It's going to store hashes. It's going to store some metadata about who uploaded that hashes. But the interesting thing here is actually the application. So I'm going to open up this application if I can find it. Here it is. Kaleido Document Manager. Oops, I guess I clicked the wrong button there. And what we can see is that it needs the gateway API URL. This is actually the instance of our smart contract that we're talking to. It needs the endpoint for our IPFS node, and then it needs the name of the author. I've been registered inside of the smart contract, and I am associated with the Ethereum account on one of my nodes. And then I have application credentials for secure access into Kaleido. So these are all good to go here. And what we can do is we can start uploading documents. Now, this could be useful for supply chain. This could be useful for a construction scenario where we have, all of these paper-intensive methodologies, and we start having siloed information, and we have all these really slow processes that might require an intermediary, or we're susceptible to forgery, or we're losing documents, or party C doesn't know, where the heck the documents from party A are. This is just a construct, a data sharing framework that allows everyone to have reference to the same data, and you have that same source of truth, that same tamper-proof methodology that comes with blockchain once you upload this data to IPFS and then subsequently to your smart contract. Now, the other cool thing that this does, and it will make a lot of sense with supply chain, with construction, with pharmaceutical trials, et cetera, is you can do relationship mapping between these documents. So for example, we have this document 3 here, just boilerplate text that I've uploaded, and we can see that it has 2 references. It's been referenced by doc number 1 and doc number 2. So if we start thinking of, maybe an overall report that has a bunch of different documents that go into it, aggregation, processing, inspections, et cetera, and it all comes out in a big batch report. Well, maybe that batch report needs to be referenced by all of those preceding documents. And this is a very, very easy framework for folks to get started with blockchain and with private or public data sharing. So I'll show you how easy it is kind of just to use this. Go ahead and click this. And I'll also add the caveat that, even myself, knowing Kaleido pretty well, this took me like 70 seconds to stand up and configure. You literally, all you need is that Solidity smart contract, you need an IPFS endpoint, and then you need the instance endpoint for your smart contract, and you're good to go right there. So, this does not require, any modicum of, technology expertise or Ethereum expertise for that matter. This is just an open sourced Electron app expressed in TypeScript that can be extended as much as your industry, as much as your enterprise requires here. So I'll just go ahead and add a document here. Hopefully of course. Okay, so let me go ahead and just navigate back to the right directory here. Let's see, document manager. Okay, so inside of documents here, I just have some dummy boilerplate text here. This would ideally be, your inspections or your batch reports or your processing information, et cetera, or a contract for that matter. So I can go ahead and open this document, and now I can submit it to the blockchain. And this is going to be signed on my behalf by that Ethereum account associated with the node that I own. It's going to be uploaded into IPFS with this hash, and then this hash and my name is going to be written into the blockchain. So we can have, again, using the blockchain kind of just as the anchor, as the ledger, as the source of truth, and then using IPFS and this shared framework kind of as the interface into all of the documents that we care about. So boom, there I just uploaded a document. We can go to our data explorer here, go to the block explorer, click the dashboard. There it is on the blockchain. Go ahead and click on it. We can look at the transaction. We see that it came from me. We see which smart contract that it went through. It took a considerable more amount of gas than just our public or positive integer right there. And then we can see the method that we called in the smart contract. We called the add document method. There's the hash of our document. There's the name, and does it or does it not have any references? And now what we can do is we can just keep going forward from here. If another individual inside of your business network had an instance of this application running, as soon as they open it up, it's going to call the smart contract. It's going to look for all of the historical state. It's going to populate the application, or if they're super interested in absolute real-time millisecond changes, we have an API or a refresh button that you can leverage as well. So I'll just add one more document here, document number 5, and we can go ahead and just create a relationship with document number 4 and show you how easy that is to do. So there's the document. Go ahead and click on the references there. Which one do we want? We want document number 4, and just go ahead and submit that. And now if we look back at our blockchain, if we look at the data explorer, not only will we see the upload of this document, but we'll see a pointer to the fact that it also has a reference. So here's our new transaction. We can go down to the transaction right there. Go ahead and see that there's the hash for document 5, there's the name for it, and now it's a reference to document 4. So this is just, I know it's quite simple, and it's only showing publicly shareable information, but it's incredibly easy, as I mentioned, for Kaleido on your behalf to do a services engagement and extend the functionality for this, or as I mentioned, it's open sourced. expressed in TypeScript. So very, very easy for your own development shop to integrate additional services, or for instance, to add an encryption parameter before you upload these documents. So just wanted to draw everyone's attention to the fact that we have that now as well. So that's going to do it for today. Thanks everyone for sticking it out for the vast majority of the hour. You know, I droned on for quite a bit. I'm going to just share my email super quickly in the chat. If there's anything anyone wants to discuss offline, it can be technical or commercial, or if there were questions that you didn't get a chance to ask. So please feel free to reach out. And thanks again, everyone, for attending. Next Tech Tuesday, we're going to look at all of the different wallet techniques, all the different signing techniques, when you should use which. And then next Tuesday, we'll look at Kaleido private stack and show you guys how to stand that up and configure it. So thanks again for attending, and I hope everyone has a great remainder of their Wednesday. Take care.